The screen is visible. Hello. Anyone, can you reply? Is the screen is visible?
Yes, sir.
Okay. Good. So the previous class we have discussed about the voltage imbalance here. So especially for the three-phase supply, if we are going to give the single phase load, and that condition, this voltage imbalance will be occur. Suddenly we are going to add the voltage loads, heavy loads we are going to add. That is for the one phase we are going to add, another phase we are not going to add anything. And that condition, what will happen? The voltage will be imbalance here. Now the causes for that one we have discussed. The primary source of voltage imbalance of less than 2% is nothing but single load on the three-phase circuit. This is less than 2% we are going to consider. Severe voltage unbalance we can result from single phase phasing condition only. If more than 5% voltage unbalance is there, and that condition we are going to consider that is severe voltage unbalance or imbalance we are going to call that one. So up to here we have discussed in the yesterday class only. Today we are going to discuss about that is waveform distortion we are going to call here. In the waveform, according to that, so the sinusoidal waveform we are going to get. Okay, so the sinusoidal voltage waveforms we are going to get for the voltage or current at all here. So in this one, if in this one, yes, who is that? Okay, so any DC component is present, that is called, we are going to call that one as DC offset. We are going to call it. If anywhere some DC components are present over there here, so that is called DC offset. If the harmonics are there, same like this sine wave only, instead of that one like this, the frequency will changes over here now. With that, the integer value it is going to multiply to the original voltage and current. That is called harmonics we are going to call. At without any integer multiplication, that is called integer interharmonics we are going to call that one. That is called interharmonics we are going to call that one. So if any notchings we are going to call, notching is nothing but the waveform we are going to get here now. This is the sinusoidal waveform we are going to get here. In this waveform, anyway, suddenly the drop like this we are going to get here now. This one we are going to get here now. So the voltage fluctuation will be occurs over there, here. That is called notching we are going to call it. So the noise also we are going to get in the waveform or in the AC system, that is called unwanted signal we are going to call that one. Noise is nothing but unwanted signal in their lamp and all the things, some chir awaz aaye, that is called noise we are going to call that. If unwanted signal, it is noise is a unwanted signal of electrical system. So in these waveforms we are going to discuss about these many the primary types of waveform distortion we are going to call this one. These all are the waveform distortions we are going to call that one. So waveform distortion is defined as a steady state deviation from an ideal sine wave of a power frequency, principally characterized by a spectral content of the deviation. Any deviations are there, the spectral content here somewhere, that is called, there are 5 primary types of waveform distortions are there. The problems are there, distortions or issues are there, we can call that one here. Those are DC offset, harmonics, interharmonics, notching, noise here. One by one we'll discuss now here. Now what is the causes for this one DC offset, what is the causes for this harmonics, interharmonics, notching, noise, that all the things we are going to discuss here. So especially by using the converters only we are going to give these many problems here now. In the electronics devices we are going to use in the lamps and all the things, the diode and half wave rectification circuits and all the things, we are going to get the DC offsets, the harmonics, interharmonics, notching, noise. These all things will comes under because of the non-linear characteristics products by using that one only here. Okay. The DC offset, the presence of a DC voltage or current in AC power system is termed as DC offset. If any DC term, DC voltage or current is present in an AC power system here, AC power system, that term we are going to call as DC offset, we are going to call here. This can occur as the result of geomagnetic disturbance or asymmetric of electronic power converters here. So previously incandescent life, the bulb life to life extent of incandescent, we were using the diodes that which one reduce the RMS value supplies, it is going to reduce, and we are by using a half wave rectification by done that one. But nowadays everyone who is using mobile charger, in the mobile charger it is going to use the DC supply only, AC to DC, the rectification we are doing, yes or no?
Yes.
So the rectification we are going to use here now. So that direct current in an AC network can have a detrimental effect by biasing the transformer core, so they saturate in normal operation here. Whatever the normal operation is there, that it will saturate, and some amount of DC voltage or current, it will flow in the system through a, it may be phase or it may be through a neutral, it may go over there. So that offsets we are going to call as DC offsets, we are going to call it. That value of that one, that is called DC offset. Suppose 200 volt is there, so some DC component is 2 is there, sorry 190 is there, 190 minus 2, 190 minus 200, the offset is nothing but we have to minus the value of that AC into that value here now. So that is 10 volts, it may be present of that DC here now. That is offset value we are going to call here now. Offset value here now. So our input is 1, 2, 3 is there. The offset value, what I will get that one. Suppose I want 4 here now. Okay, 4 minus 1, that is 1, 3. 4 minus 2, 2. 4 minus 3, 3. 4 minus 4, 0. 4 minus 5, that is called minus 1. That is offset number we are going to call that one. Like that, the DC offset, the voltage or current is present, DC voltage or current, DC current is present in the AC power system. That term we are going to call as DC offset. Main cause of this one is, example of this one is because of the rectification where we are converting AC into DC, and that one only it will flow, some leakage will be there or some flow of DC will be in the AC system here now. That is called DC offset, we are going to call that one. Will not get pure sine wave, some DC component we are going to get that one. Example I will give, half wave rectification. See here, is it full AC or DC this one? Like this we are going to get half wave rectification. You can say that one it is AC or DC. Huh? We are going to get half wave rectifier ऐसे ही आते हैं ना output. For only first half cycle where it is going to get the output. Next for negative half cycle it is 0. Next for first half cycle it is going to get. Like that, the rectifications we are going to get. Because of that, we are going to get in the AC, the DC system, DC components or DC voltage or current will be present. That one DC offset we are going to call. Next, harmonics. That is the very important thing. Here we are going to discuss about the harmonic here. So the harmonics are called, actually these are the sinusoidal, the waveform, whatever the inputs, output or input we are going to get, same like that only we are going to get here now. These are sinusoidal currents or voltages here. Sinusoidal voltages are currents here now. These have a frequencies here now. That is not the fundamental frequency. These having a frequency, that frequencies are integer multiplier of the frequency we are going to get that one. The integer value, we are the integer 8, int 16. Have you heard the name? So integer multiples of the frequency at which the supply system is designed to operate the fundamental frequency actually 50 to 60 hertz here. If it is not operating that one, if it is more than that, less than that, then that one we are going to call as harmonics. We are going to call here. These are also here for the at the 50 hertz. It is some number of cycles it is going to get. But because of this, we are going to get the magnitude same only. But the integer value here only will get some so many cycles in a half cycle. That is called harmonics. We are going to call that. The frequency variation, especially, that is nothing but the frequency variation will be occurs. If the frequency is vary, then heating problems will be produced. So many problems will be arises over there, especially in the motors and all the things. Inductive load only, these many problems will come. So harmonics are, these are sinusoidal voltages are current having a frequencies that are integer multipliers, integer multiples of the frequency at which supply system is designed to operate at fundamental frequency, that is called usually 50 to 60 hertz. So periodically distorted waveforms can be decomposed. We are going to, whatever the distorted waveforms are there, periodically we are going to decompose into sum of fundamental frequency and harmonics here. Now we are going to measure, that is fundamental frequency and harmonics we are going to consider here now. So the total harmonic distortion here now, that is called THD, we are going to call the total harmonic distortion is a measure of effective value of harmonic distortion here. This one, whatever the effective value of harmonic distortion will occur, that is nothing but total harmonic distortion we are going to call. So again, for the harmonics, so many standards are there. IEEE standard is there, IEC standard is there, okay, ANSI standards are there. So many standards are there. Based on that here now, so IEEE standard 519/1992 defines another term. It is going to define the TSD definition, that is total demand distortion. You are going to call that one. Total harmonic distortion we are going to call the general here now. But according to IEEE standard, this harmonic distortion TSD is also called as TDD. We are going to call that one, total demand distortion. As per the demand, the harmonics will be produced and it is going to create a problem for that. So that is total demand distortion they have termed here now in the IEEE standards here. So how to calculate the THD here now, the total harmonic distortion, how we have to calculate? So for that reason, it is the ratio of RMS value of the harmonic content. Harmonic content ka RMS value we have to consider to the RMS value of fundamental quantity. For the fundamental frequency, what is the RMS value of voltage or current? And for the what is harmonic content, what is the RMS value of voltage and current here now? So that is the ratio of these two. It is going to give the percentage of total harmonic distortion. It is going to give here now. So expressed as a percent of fundamental here now. Expressed as percent of fundamental here now. So next one. So here they have not mentioned voltage and current here now. So the TSD, that is called total harmonic distortion, is the ratio of root mean square of the harmonic content they have mentioned here. They have not used any word of voltage and current here. This is the content total general they are telling here. So RMS value of the harmonic content to the RMS value of fundamental quantity here now. They are using fundamental quantity here now, expressed as a percentage of fundamental here now. We are going to get the percentage of fundamental, that is TSD we are going to get here now. But by considering the current or voltage exactly here now, same definition we can add in the content place, we can add current or voltage here now. TSD is the ratio of root mean square of the harmonic current here now. See, we have used the current word here now. Here it was content here now, to the RMS value of rated or maximum demand fundamental current here. What is the maximum demand of for the 50 hertz? What is the fundamental current? That current expressed as percentage here. So TSD equal to, we can call that one whatever the fundamental for the harmonic current here, no, I harmonic, IH you can call here, no. So this is IF, that is fundamental current here. Now, for the fundamental frequency, what is the current? For harmonics, what is the current? The ratio of this one, it is going to give the percentage of THD, that is called, it may be as per the percentage, we are going to get that one here, now value here. So what are the causes for this harmonics here now? The originates the non-linear characteristics of devices and loads on the power system here now. Which devices it is going to give the non-linear characters? That is power electronics devices or converters they are going to give here now. So those are by using that product for the generation in the generation or as a load, those will produce as the harmonic they are going to produce. That is called, you can determine that in the form of total harmonic distortion. Example they are given here now. Adjustable speed drives we are using, ASD, will exhibit high total harmonic distortion values for the input current when they are operating at very light loads here. For the light loads, they are producing total harmonic values for the input current is very high, they are going to tell that one here. So just they have given here now, especially it is going to affect to the speed controls or inductive loads, it is going to affect here now. So many errors will be considered in the energy consumption, the error will come. The product in the product, suppose motor we are using, if harmonic distortion frequency flux pulses are more, on that condition the heating effect will be produces. We can in the data analysis we are using, in that situation the data may lose over there or loss of the data we can consider. Because of this harmonic, so many problems are there. So many problems will come. So this in detail we are going to study in the second unit here. The harmonics, the unit name is there, that is called harmonics here. The second unit we are going to discuss here. So next one is interharmonics we are going to call. What is the interharmonics? What is the difference? You can tell that one. Here the voltages are currents having a frequency component that are not integer multiples here. That are not integer multiples of the frequency at which the supply system is designed to operate, that is called 50 to 60 hertz here. The frequency will be same, but some integers or some harmonics will be producers, that is called interharmonics we are going to call here. We are not using any integer multiples here. If we are using they are integer multiples, then that is called only harmonics. And if they are not integer multipliers, that is called interharmonics here. Now, this is the definition here. This is the definition. Voltages are currents having a frequency component that are integer multiples, then that is called harmonics. If it is not an integer, not integer multiples of the frequency, that is called interharmonics. We are going to call that one here. So they can appear as discrete frequencies or as a wideband spectrum we are going to consider. The discrete frequencies, they can appear, or wideband spectrum we are going to call here now. So interharmonics can be found in networks of all voltage classes here. Anywhere these interharmonics are almost, these are the commonly available, that is called first harmonics we are going to call that one. Whatever the sine waveform is there, that is called first harmonics only, that is interharmonics also we are going to call it. So static frequency converters, the causes for this one is static frequency converters here. Static frequency converter means, anyone can you tell me? Static means there is no moving parts, then also we can convert that one. So frequency converter are also called as which one? Which converter we are going to use? Frequency converter ke liye? I've heard power electronics, all of you have studied. Yes. Anyone? See, I don't know. I will ask one simple question here. No, these many, whatever the waveform distortions are there, these all are because of the conversions only. Because of conversions only. Suppose AC to DC conversion. Which circuit we are going to use? Anyone can tell that one. Next, DC to AC, DC to AC here now, DC to AC, which converters we are going to use. Next, DC to DC, which converters we are going to use. And AC to AC, which converters we are going to use here. Can anyone tell? These all things you have studied in the power electronics. I think like, huh? Bolo.
AC to DC rectifier, DC to DC chopper.
Take minute. Shivani, क्या? Shivani, हाँ. Bolo. Only you tell me about DC to AC. You tell me. Maharnavar. No. Shivani, you tell that one. DC to AC.
Inverter.
Inverter. Next. Chaitanya Howal है क्या? साक्षी काळे साक्षी. Rule number 12.
Yes, sir.
Tell that one. Anyone you can choose. Choice is yours. AC to DC, which converter? DC to DC, which? AC to AC. Which converter name we are? Just tell the name of the converter. Anyone? ये तीनों में कौन सा आंसर आते वो बोल दो मैं. DC to sorry AC to DC, which converter?
DC to DC.
हाँ बोलो.
DC to DC chopper.
ठीक है. So rule number 1, Shraddha. Ambule Shraddha, are you there?
Yes, sir.
AC to DC, can you tell? AC to DC. Daily use करते, all of you people you are using this AC to DC converters. Every day you are using here now. This AC to DC conversion, every day you are using. Anyone?
Rectifier.
Very good. Rectifier file. Okay, that is called rectifier here. Okay, this is called rectifier. Your mobile, in your mobile, you are going to convert AC to DC. The adapter charger is there. That is, it is converting that one here. So rectifier circuit we are going to use. AC to DC rectifier, DC to AC inverter, DC to DC chopper, AC to AC. What
AC chopper.
Huh?
AC chopper.
AC chopper. Next. What about voltage regulators? What it will do? Have you heard the name voltage regulators? Yes?
Yes, sir.
So that is input some voltage it is taking, and the output it is going to maintain the constant. That is also AC, and we can call that one. Actually, I don't know how many of you remembered that one. Have you heard the name of cycloconverters? Cycloconverters, have you heard the name?
No, sir.
Don't know.
Sir.
So this one actually what it will do, it will comes under AC to AC only, but it is going to change the frequency from one frequency to another frequency. It is going to change that one. Frequency converter we are going to call this one. Cycloconverters are also called, I don't know your power electronics syllabus, but it is a very important device. You have to study that one. Cycloconverters we are going to call that one. Frequency converters we are going to call that one. Like how you are going to convert the voltage and all the things like that, it will take one frequency and it will give another frequency. That is. So static frequency converters we are going to use. Those frequency converters are nothing but cycloconverters we are going to call here. So while changing the frequency, It is fundamental frequency, but it is not an integer multiplier, but it will produce some harmonics. Those harmonics which are not having any integer multipliers, that is called interharmonics. We are going to call that one. So you can search in the net and you can study about cycloconverters. Cycloconverters are also one type of converter only. It is going to convert the frequency converter. We are going to call that one frequency to another. It is going to convert that one here. So induction furnaces are there. This arcing system suddenly from one point to the high voltage engineering guy that I think you have studied this one. So insulator, air as an insulating material we are going to use. Whenever we are going to pass high voltage in this tube, then in between the spark will continue here now. The spark, okay, sparking system we are going to call that. It is going to connect that one. Here we don't have the laboratory, but so many colleges they have the high voltage laboratory. You can see the lightning sparking from here to either continuously light ki wajah se, and it will produce some hissy noise. The noise with noise and spark, it is going to connect from one electrode to the another electrode. So that is the arcing or sparking devices we are going to call. Power line carrier signals can also considered as a interharmonics here. This money, it will create the interharmonics. It is going to create over there. Especially the static frequency converters will produce the interharmonics here now. Next one we are going to discuss about, that is called notching. We are going to call here. See the diagram. By seeing the diagram, we can consider that notching means what? Mobile charger, cycloconverter. Okay. Someone has given cycloconverter name. I don't know. Kishori. Okay, very good. So here the notchings are there. See here now. Only here it is changed here now. The waveform is changed here. See here. Yes or no? See, some notchings are there here. It is in the waveform only. Somewhere little bit some notches are there here now, and because of this one also some noise will be produced. That is unwanted signal or flickers. We are going to call that one. Later I will discuss. Notching is a periodic voltage disturbance here. It is a periodic voltage disturbance here. Now here the voltage we are using 500 plus 500 to minus 500 we are using here now. See here the some notchings are there here now. That is disturbance caused by the normal operation of power electronic devices here now. Because of the power electronics devices only we are going to get some notches here. When current is commutated from one phase to another phase here. The commutation process we have studied in the rectification, the SCR commutation. Have you heard the name? Yes or no? SCR commutation method, have you heard? Rule number 1, Shraddha.
Yes, sir.
Commutation नाम सुना है ना?
Yes, sir.
Thyristor commutation or SCR commutation method. So to turn off the gate or the SCR, we are going to use the commutations method. We are going to use here now. So whatever the current is there, it is going to, the current is commutated from one phase to another phase. We are going to commutate that one, and that condition this will happen. So some notchings will be produced here now. This is a disturbance of voltage only. Here normal voltage it should have to come like this straight, it should have to come, but here some notching is occurred here now. Some up is there and it is again down is there. Some up is there, here it is going to notch that waveform disturbance. It is created here now. It is not a sinusoidal, it is some disturbance is created here now. So by the voltage disturbance, it is caused by the operation of power electronics devices when the current is commutating from one phase to another phase. So when the current is shifting from one phase to another phase by using a power electronic devices, and that condition this will be produces. Since notching occurs continuously, it can be characterized through the harmonic spectrum of the affected voltage here now. We are going to characterize this by using a harmonic spectrum affected voltage in this form. We are going to this one characterization. However, it is generally treated as a special case here now. Special case we are going to consider here now, because only this many parts here here, some part of the positive half cycle, some part of the negative half cycle. Somewhere it is not continuous here now. Here, suddenly it will changes and it will come to the normal position. Suddenly it will changes and it will come to the normal position here now. So the frequency components associated with notching can be quite high and may not be readily characterized with measurement equipment normally used for the harmonic analysis here now. So whatever the equipments we are going to use for the normally harmonic analysis, those are readily characterized with the measurement we are going to do that one. This is the frequency also here. How many cycles are there here? Like this, it is there here now. This is the harmonic distortion method. We can calculate by using that one. We can measure the characterize this characteristic by with the measurement we can do that one here now. This is the because of only for power electronics devices shifting the current or commutating current from one phase to another. On that condition, the notching will be occurs over there. The notching will be occurs over there. So the last point of this waveform distortion, that is called noise, we are going to call it. What is noise here now? It is an unwanted signal we are going to consider. If suddenly, if anything, suppose you can check that one, if दोनों आप दो वायर joint करने के time suddenly चिप 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 आवाज आ जाएगा, that is called noise we are going to call it. That is an unwanted signal. If anywhere loose connection is there, so we are going to get that noise here. It should not be loose connect that one. What it will produce, it is by continuous noising system and some sparking will be occurs over there and some heat will be produces continuous burning of that one over there. So that is called broadband spectral we are going to consider here now. The frequency of that one, it should be less than 200 kilohertz. 200 kilohertz it is there. What is our normal fundamental frequency? How much is there fundamental frequency?
50 hertz.
50 hertz is there, but the whatever the broadband spectral content, that frequency, it should be lower than 200 kilohertz. Up to 200 kilohertz we are going to consider here now. See here, the noise is a unwanted signal here now. This is a noise is a unwanted electrical signal with the broadband. It is a signal with, it has the frequency of up to 200 kilohertz or lower than that here now. Lower than 200 kilohertz frequency, that is superimposed upon the power system voltage or current in phase conductor here now. In a phase conductor, it is going to superimpose the power system voltage or current, are found on neutral of the conductor, neutral conductor or signal lines here now. We are going to use 3 phases and one neutral in the load side and all the things. If this unwanted signal, it may be comes from the neutral line to the phase, or it directly it can apply for the phase also here. 2 conductors we have mismatch. In between we are going to do the jointing here now. Here the unwanted signal will be produces. That is called noise we are going to call here. So by using the power electronics devices, so it is the main cause of that one. By using a power electronics devices, we are going to get the noise. Control circuits, arcing equipments, loads with solid rectifiers here now. The rectifier units, I don't know how many have used. There is no hardware you can use that one. And switching power supply here now. Switching power supply is here now. I think I don't the power substation and all the things we have visited or don't. I don't know about that one. So gang switches are there. GOS we are going to call that one. All 3 phases before the circuit breaker and that what is that one, isolators, and that is called isolators also we are going to call. We want to isolate one line, that on that situation we are going to operate GOS, gang switches we are going to operate. So suddenly by applying that one from the line to another, applying that one here, the sparking noise will come over there. Suddenly the noise will come. So switching power supplies also, it will create the noise here now. The problem can be mitigated by using filters here now. Obviously, the isolation transformers are there, and line conditioner, by using a line conditioner, isolation transformers, and by using a filters, we can mitigate this type of noise. We can mitigate here now. So it completes the waveform distortion, it is going to complete this one. It completes the waveform distortion here. Now, the sixth one is voltage fluctuations we are going to call. We already discussed about the voltage unbalance. We have discussed about voltage sag, voltage swell, under voltage, over voltage. Okay, out of this one, what is the acceptable range of voltage? Anyone, can you tell me? In per unit, you tell me. Acceptable range of voltage. If it is more than that or less than that, is not acceptable. Actual requirement is 100%, that is 1 per unit only. 1 per unit is our actual requirement of voltage or current here. This is the requirement here. Voltage fluctuation we are discussing. Okay, voltage 1 per unit required. But the plus or minus, it is acceptable. What is that range here? Now I'm asking to you people. Anyone can, you can tell that one. Any one of you. What is the range of that one? We can accept that one. It should not exceed or it should not be below that, like that. Is there any condition? Yes or no? Is there any condition?
Yes.
What is that one then?
0.1
0.1
to 0.5.
0.1 to 0.5. This is acceptable range. Shubham, 0.1 to 0.5 per inch. Is this acceptable? Next, anyone? So I will ask one question now here. What is the range of voltage sag?
0.5, 0.1 to 0.9.
0.1 to 0.9. So if the voltage is under 0.1 to 0.9, that is called, we are going to call as voltage sag. We are going to call that one. Voltage sag, we are going to call that one. What is the voltage range for the voltage swell? Swelling?
1.1 to 1.9.
1.1 to 1.9 here. No, 1.9 you are telling. Okay, 1.8 or 1.9. See here, if the voltage is less than 0.9, then that will come under the voltage sag. If the voltage is more than 1.1, then that will consider as voltage swell here. Now, so the acceptable range of the voltage is 0.9 is okay here. We can consider 0.9 to 1.1. That is no problem at all here. No, 0.9 to 1.1. That is, there is no fluctuation at all here. If the voltage is 0.8, that is less than 0.9, and if it is more than 1.1, that one we are going to call as voltage fluctuation. We are going to call it. That is called voltage fluctuation. If it is more than 1.1, that is called voltage sag. That is called over voltage also, we can consider that one. If it is less than 0.9, that is called voltage sag. Oh, sorry, 1.1, more than 1.1, voltage swell, and less than 0.9, that is called voltage sag. That is called under voltage also, we are going to call it. But 0.9 to 0.1.1, that is acceptable range of the voltage here. Now, so if the voltage is less than 0.9 and more than 1.1, that is called voltage fluctuations, we are going to call it. Again here, the changing the load and all the things, suddenly the flicker, whatever the I have taken the example of that one, suddenly we are going to switch on the load in your houses. Some light will be dim, light will be increases, the intensity will be increases. That is called, that is flicker, we are going to call that one. Variation in the voltage. If the voltage variation occurred, that is sometime it is going to blink that one. Voltage increase decrease hote rehte, like that. So voltage fluctuations are symmetric variation of the voltage envelope or a series random voltage changes here. Now this series random voltage changes, the magnitude from here you consider the magnitude of which, the whatever the voltage magnitude is there, which does not normally exceed the voltage ranges specified by American National Standard Institute here now. That is ANSI standard C84.1. That is it should not exceed the voltage ranges specified voltage ranges from 0.9 to 1.1 per unit here now. This one you consider 0.9 to 1.1 per unit. So that is called the International Electrotechnical Commission, that is IEC 6100-1, that defines various types of voltage fluctuations it is going to define. So again, the loads that can exhibit continuous rapid variations in the load current magnitude can cause the voltage variations. The rapid variation in the load, suddenly increase karne ka, decrease karne ka, those it is going to refer as that one. It will produce as the voltage variation will be occurs. That voltage variations because of the load, that is called flicker. We are going to call that one. So voltage variations that are often referred as a flicker, we are going to call that one. Yeah. So the term flicker is derived from the impact of the voltage fluctuation on lamp. Lamp mein voltage fluctuation hote, that is called flicker we are going to call here now, such that they are perceived by a human eyes to flicker here now. You can experience, you have experienced, all of you have experienced the flicker here now. That is perceived by a human eyes to flicker here now. Your eyes will blink like this. Suddenly the light will be dim and the intensity will increases. That is called flicker we are going to call here now. To be technically correct, voltage fluctuation is an electromagnetic phenomena, while flicker is an undesirable result here now. It is not a desirable, it is also undesirable result of voltage fluctuation in some loads here now. So however, two terms are often linked in standards over there, that is IEC standards and ANSI standards. They have mentioned that one 0.9 to 1.1 per unit, that is undesirable voltage, or that is called voltage fluctuations. We are going to call that one here now. So time is over. We'll just in fast I will take the attendance. You can tell that one. Okay. Roll number 1. Fast you have to tell your roll numbers. 1.
Yes, sir.
2, 3, 4, 5, 6,
Yes, sir.
7, 8, 9, 10.
Yes, sir. Yes, sir.
डोंट बी लेट है, पहले ही अनम्यूट करके रखो, नंबर बोल दो आपका, मैंने राउंड करने के बाद नहीं देता. देखो L1
Present.
12
Present.
13 14 15
Present, sir.
16
Present.
17
Present.
18
Present.
20
Present.
21
Present.
22
Present.
23
Present, sir.
24 25 26
Present, sir. Present, sir.
27 28
Present, sir. 28.
29
Present, sir.
30 31 32 33
Present, sir.
34 35 36 37 38
Present.
39 40
Present, sir.
41 42 43 44 45 46 47 48 49 50 41 to 50. Anybody is there? No. 51 52 53 54 55
57.
57. Okay. 58 59 60 61 62 63 64 65 66.
Present. 63 present.
एक अरबस तांबोळे 60 63 दोनों प्रेजेंट है. नेक्स्ट
65.
65% है, ठीक है. Okay, we'll stop here only and we'll continue in the next class.